My name is Sean Sal. I have a background in economics and healthcare microsimulation modeling. My capstone project for the Galvanize data science program was to build an early detection model for forest fires. So my motivation for the project stems from the fact that we have satellite imagery of detected fires, but it's not at all used to aid in forest fire prevention. And I don't think it's an issue of anybody having not thought of this. I think it's an issue of it being incredibly hard to actually use that imagery to aid in forest fire prevention. From my understanding, I'm not a forest fire expert by any means, and I'm kind of just diving into this realm, but forest fires move incredibly quickly, and there are so many different factors that go in: the type of forest it is, the weather, the location, how dry that forest is, and so just all those factors come into play, and it's incredibly hard to capture that in one model. So the way it currently works is that NASA has satellite imagery that gets run through this algorithm out of the University of Maryland, and that algorithm outputs this data set that holds a large number of rows that are supposed detected fires. Those detected fires could be anything from house fires to farmer burn piles to actual forest fires. The main question I was trying to originally set out to ask was, could I somehow pare down that data set and grab only those detected fires which were forest fires? Just so happens that states at the end of every day are required to submit forest fire perimeter boundaries. If you take the latitude and longitude coordinates from all those detected fires and compare those with the forest fire perimeter boundaries, you can pretty easily pare down that detected fires data set into only those which are forest fires. The issue with that, though, is that you're doing that after the fact and historically, and if you want to do that in real time, what you'd have to do is build some kind of predictive model that could take in the input, the detected fires data set, and output which detected fires are actually forest fires. And so that's the goal that I set out with at the beginning, was to kind of build this model that would take in that data set and output which detected fires were forest fires. My findings are ongoing. I think I've gotten a very good start, but I still have a bunch of data that I'd like to input into the model, and I'm still kind of reworking the model and trying to tease everything out that I can. So my hope is that eventually I'll get to some point where I can use this model, hopefully to actually aid in forest fire prevention in real time. The way that those satellite images are used currently is that at the end of every day, the Forest Services will say, here are these forest fire perimeter boundaries from states. Is there a satellite image of a detected fire to kind of back that up? Can we confirm these forest fire perimeter boundaries with these satellite images? And so that happens at the end of every day, and if you think about it, if we could know that there's a fire somewhere 2, 4, 6, 12 hours before we used to know that there was a fire there, that could help quite a bit. Theoretically, any fire, if you catch it early enough, could be put out with a garden hose, but if you don't catch it early enough, could develop into something where you're sending in choppers, you're sending in forest fire teams, and so it can get pretty expensive and pretty costly pretty fast. Right, so my current methodology has been to build predictive models that use the detected fires data set along with geographical information to maximize the ROC area under the curve. That metric will tell me how effective my model is at predicting the probability that a detected fire is actually a forest fire. After countless iterations on Amazon Web Services of fitting a logistic random forest gradient boosting model and a neural network to the data, I found that a gradient boosting model consistently outperforms the others and gives me the highest ROC area under the curve. Next steps, though, are to start including weather data, because I have yet to include that, and I think that would be incredibly helpful in adding predictive power. The only issue right now is finding a robust granular weather data set. I have robust weather and I have granular weather, but I don't have the intersection of the two.